welcome back to Advent of Code 2015, day 15. Science for Hungry People. Today you set out on the task of perfecting your milk tuning cookie recipe. All you have to do is find the right balance of ingredients. Your recipe leaves room for exactly 100 teaspoons of ingredients. You make a list of remaining ingredients you could use to finish the recipe, your puzzle input, and the properties per teaspoon: capacity, durability, flavor, texture, calories. You can only measure ingredients in whole teaspoon amounts accurately, and you have to be accurate so you can reproduce your results in the future. The total score of a cookie can be found by adding up each of the properties. Negative totals become 0 and then multiplying together everything except calories. For instance, suppose you have these two ingredients: butterscotch, capacity -1, durability -2, flavor 6, texture 3, calories 8, and then cinnamon also has some ingredients, has some properties. Then choosing to use 44 teaspoons of butterscotch and 56 teaspoons of cinnamon, because the amounts of each ingredient must add up to 100, would result in a cookie with the following properties: capacity 68, durability 80, flavor 152, texture 76. Multiplying together, ignoring calories for now, results in a total score of 62 million, which happens to be the best score possible given these ingredients. If any properties had produced a negative total, it would have instead become 0, causing the whole score to multiply to 0. Given the ingredients in your kitchen and their properties, what is the total score of the highest cookie you can make? Let's have a look. We have 4 ingredients. So if we want to mix them all, we would go, if we want to try all options, 0 to 100 of each, we would have 4 nested for loops, which is not that bad. I think we can do that. And just try all the options. So we just have to parse it first. Let's try butterscotch and cinnamon. Oops. Here real quick. We need this one, this one, this one. All these numbers basically. And we need to remove this old code. Raw.for each sort of map. Each line is an ingredient, and we can split the line and take 0, 1, 2, 4, 6, 8, 10. Maybe I can make a little data class ingredient with, well, this stuff. Do I want it? I think then it's more work. Maybe we do that later. Let's see what question 2 asks. For now we can just have a list of A2, A4, A6, A8, 10. Let's see what we get. And we should map them all to numbers. And then we just need to loop through each. replace all commas. Try again. Yeah. I mean, now we can sum it, right? Yeah, it says it's list of int and the type int above. Okay, so we just have to go through for each, do A again. Second dot for each. We just say use. Wait. We actually just need one for loop because we have 0 to 100 for each integer. In this range, we use ingredients 0. Use I times ingredient 0 plus, 100 minus I times ingredients. We can't really times a list unless we implement it. What we can do is map it times I, and then we can do 100 minus I. Each element is multiplied, then we have one list, and how do we do it? Then we multiply them. Oh, we're ignoring calories for now, so let's let this out. So the last one is calories. And then we reduce this list. X, Y, X times Y. Something like this. I don't know how to do it. Yeah. So we take each element, these two elements that are next to each other and multiply them. Multiplying them up together. So then we should have list of results dot max. Okay, wait, I just need to get this together, then I have one list. Let's try this. Wow, that's really big. Oh. It's supposed to be big, but not that big. Let's check again. So we should, what are we doing here? "44 times this plus this, right? Plus the second list." Okay, I'm not really adding them, I'm just combining the list. How does it work? Each ingredient has a list of properties. Each property I weight and then I want to add it up. What I want to do is add, and I just have two lists. Maybe I'll just write a function real quick. List int not add other list int this dot something like this. So I take each element from here and add it to each element, the same index. There. Then I'm still wrong. So, whoops. One thing we have to add is if any property had produced a negative total, it would instead become 0, causing the whole score to multiply to 0. So we can do that by adding max 0 x and max 0 y here. And we get the right answer for the example. Now our real input has 4. So what we need to do is extend this, because we're adding 4 instead of 2, which this can stay the same. The loop will be different. I think we need 3 loops actually. I, J, K, and then we just check if, then we have each 100 minus I plus J plus K. Then we need, before we do this, if I plus J plus K equals is greater than 100, then we have to skip. So only if this is true we continue, because otherwise H would be negative. So we could also say, hey, we need H to be this if H smaller than 0. But if it's valid, it's greater equals 0, then we can do it. Then we do the same thing here. Maybe we should add this here. And then we can just say each, for each, for each. So we have 3 nested loops, which is 100 equals 1,000,000 iterations. That's fine. Then we do similarly add them, but using our two, 3, using our indices J, K, and H. And actually we need another condition. I plus J plus K plus H is 300, but we have that because H is the offset one, so that's fine. And then results dot add R, and then I don't know how big these numbers get, so maybe we should use log. It's smaller than we had before, so that's a bit weird. We do get along. Let's see. Ah, it's correct. Part 2. Well, maybe I explain real quick. So in the example we did 0 to 100 and shows I of, what was it, butterscotch, and 100 minus I times cinnamon. But now we have 4 ingredients, so now we just choose I times butterscotch, or whatever it is, plus J times cinnamon plus K times frosting H times candy. Actually, sugar is one of them. And then with I plus J plus H equals 100. So we choose exactly 100 out of them, and then we just try all the options. And the way we do it is we go through 3 for loops, I, J, K, and the last one we can infer. H is 100 times, H 100 minus the other ones. Then we have like this, minus, and then we have to check that H is positive, and then we just add them all together. Where we multiply each property in the ingredient by its weight, I, J, K, and so on, so weights, and then we add all the lists together to one list of the same size, and then we reduce it to one number, which is the score of the cookie, and that's it. So let's see for part 2, your cookie recipe becomes wildly popular. Someone asked if you can make another recipe that has exactly 500 calories per cookie, so you can use it as a meal replacement. Keep the rest of the watering process the same, 100 teaspoons, same ingredients, same scoring system. For example, given the ingredients above, if you had instead selected 40 teaspoons of butterscotch and 60 teaspoons of cinnamon, which still adds 200, the total calorie count would be 500. This total score would go down to only by 57 million. The best you can do in such trying circumstances. Given the ingredients in your kitchen and their properties, what is the total score of the highest scoring cookie you can make with a calorie total of 500? So if the scoring system is the same, it still doesn't include the calories. We just have to check the calories. the calories for each cookie. For one cookie. Calories.map. Well, let's just say calories 0 times I plus 1 times j 2 times k 3 times h. Okay. Let's do calories are always positive. Then we add pair of R and calorie. Then we check something like this. True. Strange answer. Okay, let's say filter. Yeah, dot map dot first dot max. Yeah, so we filter all the ones that have 500 calories, all the recipes, and then we map the first one, or the first element, which is the result, which is the score. Get the maximum. Let's see if that's correct. And that's it. Cool. And I think here I can use max off or not. Cool, yeah. So it was important not to change the scoring system, just add the calories here and filter at the end. So we get only the cookies with 500 calories. Thanks everyone. See you next time.